In the last video, we did something very, very exciting. We worked through training an entire neural network. Some of these steps took us an hour or so worth of videos to go back through before, but we coded that in one video. So, you ready to sing the song, just to remind ourselves of what's going on? For an epoch in a range, call model.train, do the forward pass, calculate the loss, optimize a zero grad, loss backward, optimize a step, step, step. Let's test. Call model.eval with torch inference mode. Do the forward pass. Calculate the loss. Print out what's happening. And then we do it again, again. For another epoch in a range. Nah, I'm kidding. We'll just leave it there. But that's the unofficial PyTorch optimization loop song. We created some device agnostic code so that we could make the calculations on the same device as what our model is, because the model's also using device agnostic code. And so now we've got to evaluate our model. So we've looked at the loss and the test loss here, and we know that our model's loss is going down. But what does this actually equate to when it makes predictions? That's what we're most interested in, right? And we've looked at the parameters. They're pretty close to the ideal parameters. So at the end of last video, I issued you the challenge to making and evaluating predictions, to make some predictions and plot them. I hope you gave it a shot. Let's see what it looks like together, hey? So turn the model into evaluation mode. Why? Because every time we're making predictions or inference, we want our model to be in eval mode. And every time we're training, we want our model to be in training mode. And then we're going to make predictions on the test data, because we train on the train data and we evaluate our model on the test data. Data that our model has never actually seen, except for when it makes predictions. With torch inference mode, we turn on inference mode whenever we make inference or predictions. So we're going to set ypreds equal to model1, and the test data goes in here. Let's have a look at what the ypreds look like. Wonderful. So we've got a tensor here. It shows us that they're still on the device CUDA. Why is that? Well, that's because previously we set the model 1 to the device, the target device. The same with the test data. So, subsequently, our predictions are also on the CUDA device. Now, let's bring in the plot predictions function here. So check out our model predictions visually. We're going to adhere to the Data Explorer's motto of visualize, visualize, visualize. Plot predictions. And predictions are going to be set to equals ypreds. And let's have a look. How good do these look? Oh no. Oh, we got another error. Type error. Can't convert CUDA device type tensor to NumPy. Oh, of course. Look what we've done. So our plot predictions function, if we go back up, where did we define that? What does our plot predictions function use? It uses matplotlib, of course, and matplotlib works with NumPy, not PyTorch. And NumPy is CPU based. So, of course, we're running into another error down here, because we just said that our predictions are on the CUDA device. They're not on the CPU, they're on a GPU. So it's giving us this helpful information here. Use tensor.cpu to copy the tensor to host memory first. So this is our tensor. Let's call .cpu and see what happens then. Is that going to go to CPU? Beautiful. Oh my goodness. Look at that. Look at that. Go the linear layer. The red dots, the predictions, are basically on top of the testing data. That is very exciting. Now again, you may not get the exact same numbers here, and that is perfectly fine, but the direction should be quite similar. So your red dots should be basically on top of the green dots, if not very slightly off, but that's okay. That's okay. We just want to focus on the direction here. So thanks to the power of backpropagation here and gradient descent, our model's random parameters have updated themselves to be as close as possible to the ideal parameters, and now the predictions are looking pretty darn good for what we're trying to predict. But we're not finished there. We've just finished training this model. What would happen if our notebook disconnected right now? Well, that wouldn't be ideal, would it? So, in the next part, we're going to move on to 6.5, saving and loading a trained model. So I'm going to give you a challenge here as well, is to go ahead and go back and refer to this code here, saving model in PyTorch, loading a PyTorch model, and see if you can save model 1, the state dictionary of model 1, and load it back in and get something similar to this. Give that a shot, and I'll see you in the next video.